Right, question one. So all we really need to know about polarization is what is it, which waves can be polarized, and maybe what it can be used for. So these are our basic notes. So polarized light oscillates in one plane only. This is what we mean by plane polarized. That could be vertical or horizontal. Only transverse waves can be polarized, and typically we're referring to Polaroid filters, and they're used in sunglasses to reduce glare, and there's other applications as well, such as looking at stress in materials. The most important set of notes is question 2. This is a very typical question in the exam. Typically 4 marks, possibly 6 marks. So the initial wave, the incident wave, travels along the string and is reflected at the end, and it comes back 180 degrees out of phase at that point only. And then we have these 2 waves interfering. The reflected wave interferes with the incident wave. That's the key term there. Where they meet in phase, we get constructive interference, we get an antinode. Where they meet out of phase, we get destructive interference, and we get a node, and that's minimum or zero displacement. So this is probably the most important set of notes or bit of information from this video. Okay, question 3. So the first thing to do here is probably to draw what the wave looks like. It says the third harmonic, that means 3 loops. So we can see that we've got 3 loops here. We know that 2 loops represents a full wave. So this is 1.5 waves. So we could hopefully see that if this is 90 centimeters long in total, then 2 loops is 2/3 of that. So that's going to be 60 centimeters. What is the speed? That should be straightforward. V equals F times lambda. We're given the frequency. We need to work in meters to get meters per second. So 125 times by 0.6 will give us 75. Then part C, very similar to what we saw before. If it's the same tension and the same length and the same type of string, as it says in the question, it's the same wave speed. Therefore, we can just rearrange the formula to make F the subject. F equals V over lambda. But we need to work out what the lambda is. So the fundamental harmonic, that means 1 loop. So we've still got a length of string which is 90 centimeters, but now we have a loop on it, just a single loop, which we know represents half a wave. So we need to multiply 90, or 0.9, by 2 to get the length of a full wave, and then we can substitute the values and we can calculate our frequency.